Your packet has most of these notes in it, so I don't know that you really need to write much. Maybe mark down some things from my remarks that you might find useful. We're looking at two proportion Z procedures, and since we've already covered one proportion, confidence intervals, and tests, you know the basic structures. So there's really no reason for us to look at this one at a time. So it goes quickly. I mean, you got to master the overall structure, and if quiz results were any indication, there may be many of us that need to invest a little time in this. But so starting with this, let's see. Okay, so really, two sample proportion procedures, whether they be confidence intervals or tests of significance, are based on a difference. Population proportion of one, subtract the population proportion of another. So it's much like random variables when we covered them and we were combining them by adding and subtracting them, and they became one single random variable. Well, what we're going to do is sort of blend two populations into not necessarily a single population, but into a single sampling distribution, and so that we can, find sample outcomes for these comparisons or these subtractions. So when you go ahead and do this, this is kind of what we're supposed to include in our write-ups. You have to define both proportions. Now, for a confidence interval, that's not as important as for a test of significance, because a test of significance can be one direction, like greater than or less than, for the alternative, in which case the order of the subtraction is kind of a big deal. But a confidence interval and a test of significance that's not equal to, these are two-sided procedures, so really the order does not matter. But even so, define both proportions. And something else that's new here is that instead of just looking for randomness for your samples, there has to be independence. Now, as far as I'm concerned, I have never had to do any kind of a limitation because of lack of independence. Because in most cases, your samples are clearly distinct. They don't overlap. They don't share any individuals. Men versus women. Whites versus non-whites, that kind of thing. So you're not going to lose your independence too often with this. So basically, I would always go with independence and just worry about whether or not your samples were chosen randomly. All right, both sampling distributions are approximately normal. Now, these first two inequalities were what we had when we were doing one proportion Z intervals. But since we've got a second proportion that we're throwing into the mix, you have to check another pair of these products. Oh well, I'll try to enlighten you as to maybe lessen that burden a little bit, but we'll deal with that when we get to it. And both populations are at least 10 times their sample size. I, again, would not sweat too much over this. It is extremely rare that you might even consider this to be a violation. I know that we had something in the notes for one proportion that seemed like it was a little questionable, and I may have come across as though this is a major check and you've got to really drill down deep to figure out, if this one can be, verified or not. No, it's like virtually 100% okay just to say that it is. All right, so check those, and let's see. Okay, now remember on your quiz when I said don't rely on formulas, and many of you chose to rely on formulas. Great. If that's what you want to do, good on you. But look at this formula. Do you really want to have this memorized? All right, it is going to fit your overall pattern for a confidence interval. This is a sample estimate. It's the difference between two sample proportions, and then after your plus minus is your margin of error, with this radical representing your standard error. And you can see the blending of these two proportions into one sampling distribution, or at least one standard error of that sampling distribution. So yeah, we're going to do this on a calculator, And you don't have to worry about any of this stuff, all right? State the conclusions. We're 95% confident that the true difference in the blah, blah, blah proportions, all that kind of stuff, right? But it's a little bit more than that. Since you're making a subtraction here, look for 0 to see if it occurs in your interval, which is an indication that your populations aren't that different, okay? So that's really the main purpose for doing this kind of confidence interval, because otherwise, why bother? What would be the point in doing a confidence interval on the difference, unless you're looking for either 0 or possibly some other target number, but almost every case it's 0. If you have any limitations, that's where they go, right? So what do we have for large sample z-tests for differences of proportions? Well, let's see. Define both proportions, and as I said, in this case, it's going to be super important, especially if you have directional alternatives. All right, your null hypothesis is P1 equals P2, or PM for men equals PW for women, or whatever, all right? These will never be numbers, and that's going to be important when we go to do assumptions. It's just going to be one proportion equals another. All right, that's very common for a null hypothesis. In fact, it's always a conservative kind of thing. No difference, no change, no effect, no reason to challenge any claim. We'll just go with it. All right, so those are basically what makes up a null hypothesis. And it's always equal, unlike what many of you put on the quiz. Some of you opted for inequalities in your null hypothesis. That's a no-no. All right. For one being greater than the other or one being less than the other, keep in mind that the underpinning for all of this is a difference, and so your order will matter. What will happen is if you get this inequality switched and you pick the wrong direction, you'll get the right z value, but your p-value will end up being the complement of what it should have been. And so if you start getting p-values that are 0.8 or higher, and I'm not saying that can never, never, never happen, but it almost never happens, then you probably did something backwards. Just saying, okay? When you get to the not equal to, then it doesn't matter. You can get them reversed, no big deal. I think your z-score goes negative if you reverse it, but yeah. Anyhow, so that's how you set these things up. All right, so moving on to assumptions. Your assumptions are exactly the same for your two proportion z-test as they are for your two proportion intervals. The reason that this is kind of unusual is that for a one proportion z-test, we had HOP equals some number, like HOP equals 0.25, in which case we would not be using p hat, we'd be using that 0.25. But remember, back at this other slide, these are not numbers. So you don't have any number from your HO statement that you can believe to be the true parameter value. So you're just going to use sample estimates all throughout these four products. All right? So yeah, these all three are repetition of your confidence intervals. All right, if you thought that all of what you had to do for two proportion intervals was bad for the formulas, check out this one. All right, this one is just all over the top. All right, you have it's based on a difference, and by the way, this is assumed to be 0. So you've got P1, P2, or I'm sorry, P hat 1, P hat 2, P1, P2, N1, N2, but surprise, you have some P hat values in your standard error that don't have a subscript. That's because they are actually a blending of your two sample estimates, and that's called a pooled p hat, and it has its own formula. So you've got to get this formula right before you can even use this formula. So I'm just going to throw out the crazy notion that maybe you shouldn't just use any formulas. You should just pop these things out in your calculator and let it handle the formulas. Because even if you tried, Can you imagine getting this entirely right with all the areas in it that you can mess up on? Okay, so the combined pooled estimate of the common population proportion is this, all right? And yay, we're just going to report the value from the calculator with z, p-value, that pooled p-hat, maybe alpha if you want to put those on the same line, and then your conclusion is as usual, all right? So this is your assignment. It's posted everywhere. So let's go into your packet notes and look at those. All right, there they are. Okay, I actually ended up on Friday writing these out 6 times. And so I am not going to write them out again. If you need to pause to write, then pause. And you can just take all the time that you need. But I'm just going to go with what I already have and save my poor wrist. I'm in traction here. Like my whole body is in traction from having written so much. And, you know, your proportion, confidence intervals, all the inference for proportion is the most writing in all of the inference. So once we, you know, power through this, then things should get a little better. Okay, so this is on page 14, and we skip page 15. We're going to do that Monday. So you have 24.8% of 550 white adults surveyed reported they smoked cigarettes, while 25.7% of 550 black adults surveyed were smokers. Okay, the reason I have writing up here is because I have p-hat, it's percentage, but we can make it into a proportion. We have n, 550 for both, but we don't have x, and you need x and n to throw into your calculator. So, all right, you can get x by just multiplying the p-hat back into your sample size, and that'll give you x. So 134.6 is that product. I went ahead and just converted it to 136. The reason being is because in many calculators, you know, if we're doing successes out of total and the successes are people, they are countable, your calculator can give you an error message if you try to push some kind of decimal in there. So you can round up, round down. It's an estimate. Who cares? You'll be close enough to get your full credit if you do it right. So it's really, we'll go with 136 out of 550. And then we did the same thing here, and I rounded down to 141 out of 550. So that's what I'm going to put in the calculator. All right. So the PW is the proportion of white adult smokers, and P sub B is the population proportion of black adult smokers. All right. You know, SRS is assumed, samples are independent. You see I'm kind of condensing this down a little bit. Try to save a little bit of writing. Now, if you feel that since it's a survey that somebody may have gone ahead and done it randomly, that's fine. I just said I'm not sure, I'm assuming it. I will make it a limitation, but there you go. Populations are at least 10 times the sample sizes. I believe that's obvious. So then I did n times p hat, n times 1 minus p hat, n times p hat, n times 1 minus p hat. This is for whites, this is for blacks. All of them exceed 10, so the sampling distribution is approximately normal. Okay, name your interval. That's a gradable thing. And on your quiz, it was like 10 points. So, I mean, if you're not going to write out all your formulas, at least name it. Here is your 90% confidence interval. So let's call this up and let's go to a calculator page and menu, statistics, and confidence intervals, and 2 proportion z intervals. Okay, that was, I think, 136. These, I did the whites first. The order really doesn't matter for confidence intervals. That's out of 550. And then we had 136, I think, out of 550. And I think we need to change that to 0.9 for a 90% confidence interval. All right, let me just make sure I have 136. Oh, that's not right. 136 and 141. I'm glad I checked. So let's change that. So delete, and we'll do 141. All right, if you look at these things, they look pretty close together. So if we trap 0, I would not be surprised. All right, all we need is the lower and the upper portion of that confidence interval. We don't really need to report anything else. So let's just move on from here, and let's get this back up. All right, so that's where these two numbers come from. And 0 is in there, right? Because we're going from negative to positive, so we got to cross by 0. So here is the write-up. And stick to the script, people. Some of you guys came up with goofy stuff on your quiz. So we're 90% confident that the true difference between the proportion of white and black adult smokers falls in the interval from negative 0.0521 to 0.034. The asterisk just means that this is required. You don't put that on your write-up, but this is notes. Since 0 is contained in this interval, there may not be a difference between the proportion of black and white smokers at a 90% confidence level. And then I put a disclaimer for the SRS. And you can just go generic like this. You don't have to really refer to any one possible violation. But don't just write that if there are no violations, because then people are going to go looking for them. And you're just kind of leading them around, on a kind of a hopeless journey. All right, now the reason that I concluded this with at a 90% confidence level is because your interval, whether it be this problem or a different one, might have 0 in the interval, but really close to the edge, like really close. So close that in fact, if you change the confidence level, 0 can fall out. Like if we went to, 85% or 80% confidence on this one, 0 might fall out and not be included anymore. In that case, then, we wouldn't be able to note that it was there. We would note that it wasn't there, so that there might be a difference. So really all we're saying is there may not be a difference based on the margin of error that we're using, okay? Which can change with your confidence level. Okay, so pause this if you need to, get these things copied. And I'm just going to move on past the next page to the final page. And this is a two proportion z-test. And it says more likely than, so that's going to be greater than. So it is not two-sided. I'll save the two-sided for Monday because I want to kind of mix up confidence intervals with tests of significance. But I think you can still do, a test of significance for not equal to whether we cover it today or not. It's just going to be more or less the same. In fact, it's easier, right? So 430 randomly chosen adults found that 21% of 222 men and 18% of the 208 women purchased books online. All right. Is there evidence that men are more likely than women to make online purchases of books? Right? Test an appropriate hypothesis and state your conclusion in context. Now, if you think real hard, there's something missing there. And that something is they gave you no alpha value. So they didn't give you a cut point, to figure out when I should reject or when I shouldn't. Well, that makes people uncomfortable when they first start doing this. So if you don't like that, pick 0.05. Alpha's 0.05. You're entitled to do it. You can do it. You're not screwing anything up by doing it. All right, if you opt not to do it and you still feel like you need a reference point, then keep 0.05 in your head. That way, when we get a p-value, you can kind of make a mental comparison and then maybe decide whether you want to reject or not. All right, so define both populations, pretty easy. PW, population of women who buy books online. PM is population proportion of men who buy books online. And they're either the same or men purchase at a higher rate than women do. All right? They're more likely than women to make online purchases of books. Easy. All right, these are independent random samples. Men can't be women, women can't be men, and they don't mix into their respective other groups. They stay in their own. So they're independent and we're told they're random. All right. So now for here, These actually all come to decimals, and I did the rounding here, all right? So this is actually the X for the men, 47, and 37 is the X for the women. That would be, 47 would be X, 222 would be N, and that would be for the men, and then 37 would be X for the women, and 208 would be N. Okay, so name it, results for a 2-prop z-test. Oh, and by the way, all of these exceed 10, so normality of the sampling distribution is approximated, or the sampling distribution is approximately normal, and the populations are at least 10 times the sample size. Okay, now to the naming the test. Results for a 2-prop z-test. Don't say results for a z-test. There's more than one kind, right? You've already done a 1-prop z-test, now you're doing a 2-prop z-test. So if you just say it's a z-test, who knows what it is? And there are other kinds of z-tests, trust me. So yeah, be specific. All right, and let's see where this comes from. So 40, I may have to peek back and forth. My old memory just isn't very reliable. So menu, statistics, and stat tests now, and 2-prop z-test. I believe, if I remember correctly, it was 47 out of 222 for the men, and then it was 37 out of 208. Okay, I must check and see if that's right. Bear with me. Yes, that is correct. And remember, you've got to get your alternate hypothesis, your alternative hypothesis correct. So arrow into it, go to the right. All right, don't pick less than, because if you do, you're going to get the complement of your p-value. Don't do not equal to. That's going to give you messed up results too. We want greater than. P1 is greater than P2. All right? Tab down to OK, hit enter. All right, we need, okay, this did this to me earlier. All right, it gives me a confidence interval. You dog, don't do that. All right, so, all right, go get a snack or something while I set this up again. It won't do it the second time. All right, z-test, see that? All right, let's see, that was 47. All right, I'll call you whenever I get this done. So go to the fridge, get a beverage, pet the cat, stand by. All right, so we got to have a greater than. No, seriously, you saw that. It shouldn't have given me a confidence interval. I guess there's some flaws in this. All right, here we go. Oh, it's doing it again. All right, I'm just going to pause and figure out why it's doing this. Hang on just for a second. All right, so third time was a winner. Winner, winner, chicken dinner. All right, so what do you record? You record the z value, this one right here. You record the p value, this one right here. And then this p hat without a subscript. See, this has a 1 and a 2, but that doesn't. You record that. If you've picked an alpha, that can go in the next line, all right, which I didn't do. Okay, so what do we do? All right, here's your p-value, 0.1883. And I asked the kids, is that fairly large? Well, it's not fairly large, like hugely large, but it's bigger than 0.05, right? So if you were to compare it to alpha, you would fail to reject, right? Because you would see this sample result that we just worked on about, well, it's pretty close to 0.2. That would be 1 out of every 5 samples, which is not rare, okay? That can happen all the time. Anything below 0.05 would happen less than 1 out of 20 times, and that's pretty rare, okay? So there's seeing a sample result like this happens about 18% of all samples that we would get, and that really doesn't challenge your HO. So since your P is sufficiently large, the results are not significant and we fail to reject HO. All right, that first line needs to have all 3 of those elements. State something about P, either it's large or small, whatever, how it compares to your alpha if you picked one or if you were assigned one. Then say whether or not it matters, if it's significant or not, and then say what you're going to do with your hypotheses. You're either going to reject or fail to reject HO. That's it. Don't mention HA. Then all you have to do is tell your reader what that means in context. And sorry, I missed my RE here. So there is not sufficient evidence to believe that the proportion of men more likely to buy books online is higher than that for women. That's it. Done.